Okay, so we're going to look at part 2 of the Chapter 7 review. So Chapter 7 review ended at question 7, which was to maximize this function, our objective function, given these 4 things. Okay, so these two together put it in quadrant 1. And then with these two, I just need to solve it for y. So we'll subtract 2x and divide by 5. So you get y greater than or equal to negative 2/5 x plus 2. So there's an equation I got to graph in quadrant 1. And then this one will subtract 5x. So we get 2y less than or equal to negative 5x plus 10 divided by 2. Remember, you change the sign when you multiply or divide by a negative number. So we have y less than negative 5/2 x plus 5. Okay, so then we can grab some graph paper here, and we will graph those equations out. Make sure that you're making your graph big enough to see those. And notice again, I am in quadrant 1 because x and y are both greater than 0. So we're shading these in those directions. Okay, so the first equation we had was starting at 2, and it went down 2 and right 5. So down 2 and right 5. 1, 2, 3, 4, 5. Okay, and then there's that line. And it says y is greater than that line, so this one's actually shading above. Okay, and then the next line will start at 5, 2, 3, 4, 5, and it will go down 5 right 2. So 1, 2, 3, 4, 5, 1, 2. There. Okay, and so y is less than that, so I'm shading this way. Okay, so when we look at where we're shading here, okay, we're obviously going to shade anything in this square, but it needs to be bigger than this line and less than this line. So that actually leaves me right in here. Okay, right in there. So I need to find those ordered pairs of these vertices. So I know I have 0, 2, and I know I have 0, 5. But in order to find this intersection, I actually have to solve out this system with these two equations. Okay, so I'll just do that here on this graph paper. So I already have that y equals negative 2/5 x plus 2, and y equals negative 5/2 x plus 5 equals y. Well, since I have y equals on both of them, I can actually just set these two equal to each other and get rid of the y's. Okay, then I'm solving for x. So let's subtract 2 here, and we'll add 5/2 x. So that cancels, and that cancels. So I get 3 on this side, and you have negative 2/5 plus 5/2. If you get a common denominator of 10, this is negative 4 over 10 plus 25 over 10. And negative 4 plus 25 is 21 over 10x. We will multiply by 10. So 21x equals 30. And we'll divide by 21. So x equals 30 over 21, which can be reduced. If we divide by 3, that's 10 over 7 for x. Now to find y, we just plug that back into one of those equations. So we had y equals negative 2/5 x plus 2. So if I plug that in for x, it's negative 2/5 times 10 over 7 plus 2. So this 5 cancels with the 10 to make it 2. So you get negative 4 over 7 plus 2, which is 14 over 7. And you get 10 over 7. So actually this point right here is 10 over 7, comma 10 over 7. So 10 over 7, comma 10 over 7. That would be that point right there. So we've got those 3 points. Now we're going to take our optimization function, which is right here, and we have to plug those 3 points in to see which one is the max. So when I plug in, let's see, 0, 2, I get 5 times 0 plus 7 times 2, which is 14. When I plug in 0, 5, I get 5 times 0 plus 7 times 5, which is 35. And when I plug in 10 sevenths, I get 5 times 10 sevenths plus 7 times 10 sevenths. Now I'll do that in the calculator here. So we have 5 times 10 over 7 plus 7 times 10 over 7, math fraction. That's 120 over 7, which is about 17.14. Okay, so then your max would be right here. So you'd have a maximum of 35 at, so max of 35 at 0, 5. Okay, so that's number 7. Number 8 says give the exact solution of this logarithm. So let's write out this logarithm here. So we have log base 5 of x plus 2 plus log base 5 of 6 minus x equals log base 5 of 3x. Okay, so because I have 2 logarithms here, I combine over addition with multiplication. So log 5 base 5 of x plus 2 times 6 minus x equals log base 5 of 3x. Now I'll take both sides to the base of 5 to get rid of the logs, so those cancel. And you have x plus 2, 6 minus x equals 3x. And now we've got to get rid of parentheses, so we will distribute, FOIL all that out. So you get 6x minus x squared plus 12 minus 2x equals 3x. This is a quadratic, so we need to set it equal to 0. I'm actually going to move everything to the right-hand side to make it positive x squared. So we have x squared, and we subtracted 6x to the other side. So you get minus 3x, and then plus the 2. Sorry, 6 and negative 2. So negative 3 plus 2 is negative x. Minus 12 equals 0. We can factor this. Factors of 12 that subtract to 1, that's 4 and 3. Signs are different. The bigger one is negative. So x is negative 3 and 4. Now with logarithms, you have to check this because I cannot have 0 or anything less than 0 in the logarithm. So you note that if we plug negative 3 in here, I get negative 9, and I cannot have that negative 9. If we plug in 4, that's 6 here. 6 minus 4 is 2, and 3 times 4 is 12, so that one is good. Okay. Number 9 says find all the zeros, and then it gives you this equation right here. Okay. So we'll say x to the 4th plus x to the 3rd plus 2x squared plus 4x minus 8. So I'm looking for 4 zeros here, and we can find a couple just on our calculator. Okay, if I go to graph this thing, x to the 4th plus x to the third plus 2x squared plus 4x minus 8. Zoom standard here. I can see two zeros right here, and those are -2 and 1. If we don't know that, we can calculate. So if you go to second trace, you go to 0, number 2. It's going to ask you for a left bound. So just go to one of these zeros and make sure you're on the left side of it. Whoop, I'm on the right side. Okay, so I'm on the left, so I'll hit enter. Then it says right bound. You go to the right of it, which I am, hit enter. It'll say guess. You can just go ahead and hit enter, and it'll spit back 1. So that's actually 0. So with the 1, I'm going to do a 0 of 1 with synthetic division. So I have 1, 1, 2, 4, -8. Remember, if there's not a term in there, you got to put a placeholder of 0. So bring that down, multiply, add, multiply, add, multiply, add, multiply, add. So you get 0, so it is a 0. So now we'll do -2, right on down with that. Excuse me. So 1, multiply, add, multiply, add, multiply, add. So you've got your zeros being 1 and -2. But then I have this x squared plus 4, which we can factor and go ahead and find the zeros. Now, it's not a difference of squares yet, so we'll rewrite it. We'll say x squared minus -4. So now it's a difference of squares, and we will factor that as such. So you got x plus and x minus, and when you factor it, it's a square root of this. Well, the square root of -4 is plus minus 2i. So here's your plus, here's your minus. So you get 2i, 2i. Now, those aren't the zeros. Those are actually the factors. So if I set these equal to 0, x is negative and positive 2i, which is kind of what we had right there. So your zeros, your 4 zeros, are 1, -2, plus minus 2i. Okay, so now we will take a look at, let me move this around here. Now we're going to take a look at number 10. Okay, number 10 talks about graph and tell what happens to the parent function. So, and give domain and range. So we have this quadratic. I know it's a quadratic because of the x squared. So I've got y equals -1/2 x plus 1 squared minus 3. So remember, from way back when, we have the HBAK. Okay, and this is a parabola, like I said, because of the x squared. So this will go left 1. This -1/2 here, the negative will, there is no b, b would be right here. This is a, so it goes over x and shrink by 1/2, and the 3 goes down 3. Okay, so then we graph out our parent function. Now let me use this graph paper here. So if we graph out this parent function, okay, so I'm 0, 0, 1, 1, 2, 4. And then -1, 1, there. So here's your parent function. Now, what's happening with this parent function is that all the points are going left 1, like we said. They're going left 1, over the x, shrink by 1/2, and down 3. So if I take this point right here, and I move it left 1, right here, and then I go over the x, it doesn't move. If I shrink it by 1/2, it doesn't move, and then I go down 3. So there's that point. And you're doing this for every single point. So if I'm here, I go left 1. I flip it over the x-axis here. I vertically shrink it by half, meaning I multiply your y value by half. So -1 times a half is -1/2. And then I go down 3. 1, 2, 3. Now, parabola has an axis of symmetry right here. So this point actually gets reflected over here because this is now your axis of symmetry right there. So if I move this one, left 1, I go over the x-axis. So now I'm at -4. Multiply it by half, I'm at -2, and I go down 3. 1, 2, 3. And I reflect that. So now your parabola looks like this. And then we have the domain, which is all reals. And we have the range, which the range starts at -infinity to -3, and I can actually have that number -3. So now we have number 11, which is solve. So I have the square root of 2x plus 1 plus x equals 7. So I got to solve this. So we are going to isolate the radical, so minus x. And then to get rid of the radical, we square both sides. So you have 2x plus 1 equals, then I got to multiply this out, 7 minus x times 7 minus x. So you get 49 minus 14x plus x squared. Again, we have a quadratic, so we'll move everything to the other side. So we have 0 equals 48 minus 16x plus x squared. So I'll just rearrange it so it looks a little bit better. Okay, so there we go. So now we need to find factors of 48 that add to 16. Now, if finding factors is something you have difficulty with, just start making a list. Out here, write 48 and just start thinking of the ones. So you got 2 and 24. You got 4 and 12. Okay, well, right there, those two add to 16, so you're done. So you got x, 12 and 4. Sides are the same, they're both negative. So x is 4 and 12. Now, again, you need to go back and check because right here, you can't have a negative under here. Okay, so if we plug both of these numbers in, 4, we get 2 times 4 is 8. 8 plus 1. Excuse me. So you got 4 times 2 is 8. 8 plus 1 is 9. Square root of 9 is 3. 3 plus 4 is 7. Okay, plug your 12 in there. 2 times 12 is 24. 24 plus 1 is 25. The square root of 25 is 5. 5 plus 12 is that 7? No. So then you just get 4. So in this case, there was just one answer. Okay. Okay, so the last one here. A boat travels from Kansas City to St. Louis in 10 hours with the current with the current, and on the return trip, it takes the same boat 15 hours. Obviously, that's against the current. How fast is the current moving? The average speed of your boat during the trip to and from St. Louis is about 30 miles an hour. Okay, so word problems, we like to draw pictures. So we have Kansas City and we have St. Louis. Okay, the boat, it says a boat travels from Kansas City to St. Louis in 10 hours. So 10 hours with the current on. With the current. So it's going a speed of about 30 miles an hour plus the current. Okay. And then on the return trip, let's see, do I know it takes 15 hours? Okay, and we have the 30 miles per hour minus the current because you're fighting against the current on the way back. Now we know the distance between Casey and St. Louis is all the same. So your distance to equals your distance from St. Louis. And distance equals your rate times your time. Okay, so your rate there is actually right here. 30 plus C times your time is 10 hours equals your rate of return, so 30 minus the current times the 15. Okay, now when I solve this, I will actually get the speed of the current. Okay, so we distribute. You get 300 plus 10C equals 450 minus 15C. Let's see, we'll subtract 300. 150, add 15C, 25C, and then you'll divide by 25, and the current is 6 miles per hour. Okay, so you just have to pay attention as to which direction the current is going in order to figure out how fast it is. So there might be an extra credit question on there. 15 questions, 2 word problems, 1 true false, and then there's 5 parts to that true false. Graphing, 9 from chapter 7 and 6 from past chapters is kind of how your test will break down. So yeah, if you got questions, please let me know. This is at GHS Mr. Jones signing off.